Hey, my name is Samuel Graham, and I'm Associate Professor at Georgia Tech in the Department of Mechanical Engineering. I became interested in mechanical engineering basically when I was a young child. My dad was in the military, and I was always interested in looking at military equipment. He was in the Army. I had a chance to actually get inside of tanks and other military equipment and see airplanes, and I always wondered how that stuff worked. And so my curiosity into machinery and mechanical objects basically was started at a very, very young age. And so I looked for opportunities as I was growing up to go to universities and actually inquire about mechanical engineering and other forms of engineering, just because I was that inspired when I was younger. I was able to work as a researcher, a visiting researcher at Stanford University during my time at Sandia National Laboratories in Livermore, California. And I found that the environment within the university, what I found at Stanford, basically really spawned my curiosity and my drive in working with students. I had come through a university environment as a graduate student myself, but I found that I really missed the environment, the intellectual curiosity that you find there, and the ability to change directions just upon a conversation that you may have at lunch to be able to pursue your dreams. And so that's how I ended up in academia. I found that I really enjoyed my time, and I thank Professor Ken Goodson at Stanford University that allowed me to come over and work with his group. And I'm still friends with a number of those students that were in the group today. So it's very influential in me pursuing an academic career. Well, we hope that this research will benefit society, number one, not necessarily in just producing new gadgets. That's something that's quite easy to do, but it doesn't necessarily benefit society just by producing another flashy object. We want to develop technologies that help with the areas of energy, both storage and energy utilization and energy production. So in the area of organic photovoltaics, we're wanting to make devices that can actually turn solar energy into electrical energy to help power either handheld portable devices or even produce enough power that can actually be used to produce energy for the electrical grid that could be used in your home. In the area of things like flexible batteries, we'd like to be able to produce devices that can store energy, again, on flexible substrates that you can carry with you quite easily. And in the area of solid-state lighting, we'd like to be able to make organic light-emitting devices, not only for displays, but materials that can actually be used for general illumination, meaning they can light up your room. You could actually replace the light bulbs in your house, inside and outside, with flexible panels that could be used for lighting. And the nice thing about these materials is that they use much less energy, and so we would be looking at a technology that would not only have the light bulbs last longer, but one that would consume less energy and help to address the energy concerns that we have in the United States and around the world. Well, the thing that I find very exciting and inspiring is that now that I'm in this area of looking at flexible thin films, flexible electronics, combining them together to make brand new devices, I'm constantly being stretched to learn new things. There's no way that I can actually go about working on the packaging of these devices without interacting with electrical engineers to understand the operation of these electronic devices, a little bit of the physics of the devices, as well as interacting with chemists to understand a little bit about the materials that go inside of the devices. So it's a constant learning curve for me, but it's one that's an enjoyable ride. So I think that's probably a challenge, but also something that keeps me energized, because I feel like I'm constantly learning, and I'm constantly, the more that I learn, I feel like I'm constantly learning how to create the next object that's going to come up in the future. So from that point of view, if you want to see what the future looks like, you want to come and work in an area like this that's just groundbreaking, that you have the opportunity to shape the future by the ideas you have today. So for a mechanical engineering or material science student that's interested in or even considering going into the area of organic electronics, especially looking at packaging and how these devices are fabricated and made, I would suggest that you use your intellectual curiosity to begin searching out the area either by simply asking your current professors questions or looking at things on the web. But more than that, I would say get involved in some research early on to really tell if this is something you want to do, either on your current campus, or there are a number of universities throughout the country that have research experiences for undergrads. Apply for those and go give it a shot and see if this is something that really piques your interest, or this is something you think that you could work on long term. I think that for most mechanical engineering students, at least, this is not an area that's often taught or talked about at the undergraduate level. However, there are clearly technologies that we work on in mechanical engineering that can benefit this area, mainly in the areas of manufacturing and electronic packaging. A lot from those areas can be brought over and brought to bear against the challenges we have with organic electronics. So even if you don't have someone on your campus that is doing things with flexible devices, still talk to professors that are in the general area of electronics packaging, and they can give you some ideas of what's going on and help you learn some of the technologies that you can take over into this exciting field. But again, the main thing is to find someone that is working in this area, ask them questions, learn as much as you can from them, and be driven. Don't take no for an answer. If it's hard to find the very first time, don't stop. Keep looking and take advantage of the REUs. I think it's a great way to learn.